So here's where we got to at the end of last week's screencast. We had a script that asked for your name and printed it back out to you using fprintf. So what we're going to do this week is show you a bit more features of fprintf, and also, write a program that's a bit more useful for physicists, and also spin off a function from that program so we can learn about how to write our own functions. So first of all, I'm going to save this script as a different name, so I've got somewhere to start from. I'm going to put it in my directory called week 2, and I'm going to call it energy converter. Okay, so this is a script. Alright, and now I need to change the current folder so it's where I want it to be. So let's find the right directory. Here it is. Okay, and now I'm going to edit the script so that everything matches the new file name. And I already know what I want this script to do. I want it to prompt the user for an energy in electron volts and convert it to joules. Prompt the user for an energy in EV and convert it to joules. Okay. So first thing I want to do is ask the user to type in an energy in EV. So the question, or the prompt for information is give me EV, and this time I want a number, so I'd remove that S. I don't want a string this time, I want a number. Okay, and then what I want to do is I want to convert the value in electron volts to joules. So I'm going to define a variable called electron charge, 1.6 times 10 to the minus 19, which is the conversion factor. And then I'm going to write joules equals EV times electron charge. And that gives me the answer, doesn't it, for converting between joules and electron volts. So now I just need to write out the result. So I'm going to use fprintf again. But this time I've got a number that I want to write out. And I'm going to write out the energy that was input by the user in electron volts, and I'm going to write out its equivalent in joules. So before we were using fprintf to write out strings, and that was with the %s format character. If you want to write out a number, then there are different format specifiers for that. So let me write them out and then I'll explain what they mean. So I'm going to have a floating point number for electron volts, and then I'm going to have a scientific notation number for the joules, and I'm going to finish it with a new line. Okay, so here, this bit, F stands for floating point. 5 is the total number of characters in the output, and 1 is the number of characters after the decimal place. So this will print out, you could put a comment here, 5.1f will print something like, let's say if it was, it could be 123.4. So that's 5 characters across, 1, 2, 3, 4, including the point 5, and 1 character after the decimal place. And the other one, 8.2e, this will print something like, now it'll be 1.23e minus 19. So there's 8 characters across the entire field, 4 to here, and then another 4, 2 after the decimal place. Okay. So the program prompts the user for a number in electron volts, defines the variable to do the conversion, does the conversion, joules equals electron volts times electron charge, and writes out such and so electron volts is such and so joules. Okay, let's give it a test and see if it works. It's called energy converter. Give me EV. Okay, let's say 1 EV just to test. 1 EV is 1.60 times 10 to the minus 19 joules. So that's good, it works. Let's try 0.2. 0.2 EV is 3.2 times 10 to the minus 20 joules. So that appears to work. There are two things which are not so nice about this script though, the way it is. The first is that if I run it and give a very big number for EV, so let's say I give it 100,000. Now the format has not been adhered to because 100,000.0 is not in the format 5.1f. So what we could do if we wanted to is we could trap when the amount of electron volts is bigger than a certain number and then change the format statement to match it. So we could say if EV is greater than say 10,000, then we'll write the amount of electron volts in scientific notation as well. So we change the format statement to show that. And if it's not greater than 10,000, we'll keep what we had before. So we'll copy this line, paste it here, and turn that back to 5.1f, and then end this block, end this if block. So I'll write a little comment here. Test whether EV is a big number and use a different format statement if it is. Alright, let's try that then. So now if we run it and put in the big number, it writes out the amount of electron volts in scientific notation as well. But if we go back to a small number, it writes out in the previous format. So that's quite useful. Another thing that's not very good about this function as it stands is that if you give it nothing, you just press return now, it still tries to do something, and that doesn't look good. So we can trap that too. We can test if EV actually contains something. So what we can do is we can say if, and then is empty, the function is empty, whatever you give it as the argument. If this says if EV is empty, then do this bit. So here you can write a comment, EV was empty, so display an error. Okay, and then you have to put end. And the way this works now, if you use the error function, is you can put EV was not specified. An error, the function error, will actually terminate the script. So in this case, if electron volt is empty, this command error, this function error, will stop the script. So it will never get to this bit. So now if we run it, give it a number just to make sure it still works. Yes, it still works. But now run it and don't give it anything, and it gives you an error. So that's how you can throw an error from your own script and terminate the execution of the script. But you don't always want to do that. Sometimes you want to know if a variable is empty or if it's not been specified properly. But you don't want to terminate the script. You want to deal with it. So in this case you could say disp no energy specified. And now you can change this to else. So now this next chunk now will get done if EV is not empty. And you know, to make it look nice, you should indent everything using the arrow keys and tab if you like. Everything gets indented, and then you have to finish the if block. See how it highlighted it here? When I type end, it highlights which it matches with. Alright, so what this will do now is if you don't give it an energy, it will just display no energy specified, but then it carries on, so it doesn't see this bit because that condition wasn't met, but it carries on to the bottom of the program. So it won't throw an error this time. So that time when I ran it and gave it nothing, it didn't throw an error. Give me EV, give it nothing, it just says no energy specified, and then the program is finished. So as usual, you can give it a number and it works just before, as before, or you give it a very big number. You can even type these big numbers in scientific notation and it will convert it for you. Finally this week, let's make a function of our own that does the conversion. So we can call a function here on this line where it says joules equal. So it'll be a very simple function, but it'll be a function we'll be able to use anywhere in any of our programs. So let's create a MATLAB function. Let's go here, new function. And MATLAB will give you a skeleton of a function definition. I'm going to call this function, so I'm going to save it as, to give it a name, I'm going to call it EV to J, so electron volt to joules. Save that. Now you have to update this skeleton to reflect the name you've chosen for it. So the name of the function goes there, and it also goes here, and the summary goes here. So converts electron volts to joules, and a detailed explanation goes here. So in this case, you can, it's not really very necessary, but uses the charge on an electron to convert the units, for example. Okay. The output arguments, you can have more than one, but for this there's only one, so that has to be the name of the variable that you're going to define in the function. That's what gets returned to your program. And input arguments is the name of the variable you're going to use in this function of the number you're passing to it. So straight out of the other program, define the electron charge to be 1.6 times 10 to the minus 19. And then this variable is the variable that's going to be output. It's called joules. And that equals the input variable EV times the electron charge. And then that's it. That's the entire function. You told it here the variable that gets returned. So as long as you define that variable, it will work. So you can test it on the command line. To start with, you can say joules equals EV to J, that's the name of the function, and then give it a number in electron volts. So let's give it 1, and joules comes back as 1.6 times 10 to the minus 19. Let's give it 10, and it comes back 10 EV is 1.6 times 10 to the minus 18. So it's working, okay? So now save that and go back to our other program that we were writing, energy converter, and now we can replace this block here with a call to the function. So the call to the function looks like exactly what I typed on the command line, EV to J, and then you pass in the variable EV, and that will do exactly the same thing. So now we can run that script that we had before, 0.2. It works. And this is one of the most powerful things about programming, is that you can modularize your code and reuse it anywhere. So this example is a very simple function, But you can imagine that there could be a function you write that does something much more complicated than that, and it means you don't have to keep cutting and pasting the code into your script. You can just use the function call. And don't forget that because of the way you wrote the comments, if you do help ev to j, it prints out a nice help statement. Okay, that's it for this week.